Okay, Assalamualaikum and a very good morning to everyone. So today kita akan mula dengan new chapter which is chapter 4, chemical bonding, and we're going to start with the Lewis dot symbol and also the chemical bond. Okay, so by the end of this lesson, okay, you should be able to write the Lewis dot symbol for an atom. The second one, you should be able to state the octet rule and to describe how the atoms obtain the octet configuration. And the last learning outcome is to describe the formation of the following bonds by using Lewis dot symbol. So in this chapter, kita akan cover 3 different type of bonds, which are ionic bond, covalent bond, and also the dative bond. Okay, so we're going to start with the Lewis dot symbol. So before we go further into the chemical bonding, macam mana bond itu terhasil, kita kena belajar macam mana kita nak tulis ataupun macam mana kita nak represent the valence electron for each of the element. Okay, so for at this level, we're going to use a Lewis dot symbol. Okay, so Lewis dot symbol is basically was proposed by a guy named G.N. Lewis in order to simplify a way for us to represent the valence electron for each element, and in order for us to easier to track the movement of the valence electron throughout the reaction. Okay, Lewis dot symbol ni senang saja. Yang pertama, you need to have the symbol of the element to represent the nucleus, and the second one, we need to draw either dot or cross to represent the valence electron, and the number of the dot or crosses, okay, depends on the number of the valence electron of the element. Okay, so for example, kalau saya ada sodium, okay, we know that sodium is located in group 1. Okay, that means sodium must have 1 valence electron. So the symbol of the element, okay, this is the symbol of the element. It represents the nucleus of the atom. Okay, since sodium only have 1 valence electron, we can either draw 1 dot ataupun we can either draw 1 cross to represent the number of the valence electron. Okay, so maknanya kalau elemen tu ada satu valence electron, maknanya dia hanya ada satu dot ataupun hanya ada satu valence electron. So another example is beryllium. Okay, we know that beryllium is located in group 2. Okay, group 2, that means beryllium have 2 valence electron. Okay, so cara kalau kita ada lebih more than 1 valence electron, okay, kalau awak lukis dia macam ni, sebelah menyebelah, okay, ini adalah salah. Kerana in order to arrange the electron in the orbital, we need to consider the repulsion. So kalau elektron itu berada berdekatan antara satu sama lain, the repulsion will be higher. So in order to minimize the repulsion, okay, lagi satu elektron tu kita akan letak dia dekat opposite side. So repulsion dia akan makin berkurang. So ini adalah yang betul. Okay, so for example is carbon. Okay, carbon is an element located in group 14. That means carbon have 4 valence electron. So nak lukis the Lewis dot symbol, kita lukis, ingat direction dia atas, bawah, kanan, kiri. So 1, 2, 3, 4. Ataupun awak boleh tulis dia sebagai dalam bentuk cross. So 1, 2, 3, 4. Okay, another example is chlorine. Okay, chlorine is an element located in group 17. That means chlorine have 7 valence electron. So kita lukis 1, 2, 3, 4. Okay. And then 5, 6, 7. Okay. Another, the last example is neon. Okay, neon is group 18. That means neon have 8 valence electrons. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, this is the Lewis dot symbol. Remember that in the Lewis dot symbol, the symbol of the element, dia akan represent the nucleus of the atom, and you represent the valence electron by using either dot or cross. Okay, and the number of dot or cross depends on the number of valence electron. Okay, so now we learn about the Lewis dot symbol. Okay, before we start in detail pasal chemical bond, kita akan tentang octet rule. Okay, so octet rule by definition, okay, atom, okay, cara nak atom itu nak achieve octet by either gaining, losing or sharing electron until the atom are surrounded by 8 valence electron. So maknanya in order to become stable, the ion become stable, the atom must have 8 valence electron surrounding the atom. Dan macam mana atom itu nak dapatkan 8 valence electron? It can be either by gain, losing or sharing electron. So kalau by gaining or losing electron, ini selalunya adalah during the formation of ionic bond. Okay, kalau sharing electron yang macam awak belajar dulu waktu sekarang mendengar adalah formation of the covalent bond. Okay, now we learn about the octet rule. Kita boleh proceed with the stability of the ion. Okay, we have 3 different type of stability of ion. So we have the noble gas configuration, pseudo noble gas configuration, and also half fill orbital stability. Okay, so for a group 1, group 2 and group 13 element, okay, dia akan donate its valence electron to form cation. Okay, and the cation form from the group 1, 2 and 13 will have a noble gas configuration. Maknanya dia punya electronic configuration of the ion akan sama dengan electronic configuration dari salah satu elemen daripada group 18. Okay, so for example, sodium. Sodium is an element with 11 proton. So this electronic configuration for sodium is 1s2, 2s2, 2p6, 3s1. In order to achieve octet, okay, sodium need to remove 1 electron. Okay, and the electron will be removed from the highest energy orbital, which is for this case is the 3s orbital. So when sodium remove 1 electron, the sodium ion will have electronic configuration of 1s2, 2s2, 2p6. So 1s2 to s2 to p6 adalah electronic configuration dia sama dengan neon. So we call it as the sodium ion isoelectronic with neon. Okay, for a group 15, 16 and 17 element. Okay, tadi group 1 to 13 dia akan donate electron to form cation with the noble gas configuration. Tapi group 15, 16 and 17 element, it will gain electrons in order to form an ion with a noble gas configuration. Okay, so for example, oxygen is an atom with 8 electrons. So the electronic configuration for oxygen is 1s2, 2s2, 2p4. In order to achieve octet electronic configuration, oxygen need to gain 2 electron. Okay, dan 2 elektron itu akan masuk dekat 2p orbital, sebab kalau awak tengok only 2p orbital yang ada available, yang ada tempat kosong untuk kita masukkan elektron. So the electronic configuration for O2 minus is 1s2, 2s2, 2p6. Which is kalau kita tengok dia ada sama electronic configuration dia dengan neon. So we call that the O2 minus will have the same electronic configuration with neon, thus it have the noble gas configuration. Okay, the second type of stability of ion is the pseudo noble gas configuration. Okay, kalau awak tengok pseudo ini maksud dia adalah false. Maknanya dia bukan noble gas configuration. Tapi kita panggil dia pseudo noble gas sebab apa? Sebab all the orbital are fully filled. Macam kita tahu kalau dalam noble gas, semua orbital yang ada dalam atom itu fully filled with the electron. Same goes with a pseudo noble gas configuration. That means semua orbital dalam ion itu akan penuh dengan elektron. Okay, normally the pseudo noble gas configuration ni happen dekat D block element, which is the transition element. Okay, so we know that D block element, it will donate the 4s electron in order to form cation, okay, with a pseudo noble gas configuration. So for example is zinc. Okay, zinc dia ada 30 elektron. So the electronic configuration for zinc is 1s2 until 3d10. Okay, between 3d10 and 4s2, in order to form Zn2+, in order to remove 2 electron, ingat kita kena remove from 4s sebab once we fill up the 4s orbital with electron, 4s tu akan jadi higher energy compared to 3d. Okay, so when we remove 2 electron from the 4s, okay, Zn2+ ion akan ada electronic configuration yang ini sampai 3d10. So kalau awak tengok setiap satu orbital itu is a fully filled orbital. So maknanya setiap orbital itu penuh dengan elektron. That's why we call it as a pseudo noble gas configuration. Maknanya dia tak ada configuration yang sama macam noble gas, tapi kita panggil sebagai pseudo noble gas sebab kesemua orbital itu adalah fully filled. Okay, and the last stability of electronic configuration of the ion that you're going to learn is the stability of half-filled orbital. Okay, this one also happen dekat D block element. Okay, D block element juga dia boleh donate dia punya electron in order to achieve stability of half-filled orbital. So for example manganese, okay, manganese the valence electron is 4s2 3d5. Okay, so in order to form Mn2+, we need to remove 2 electron from the 4s. So sampai dia akan jadi 3d5. So kalau awak tengok 3d5 adalah half filled. So we know that half filled is a stable orbital. So that's why we call it as the stability of half-filled orbital. Okay, so for example, okay, write the electronic configuration, okay, and then state the type of stability of the ion form from the atom chlorine. Okay, chlorine, the proton number for chlorine is 17. Okay, and then kita nak tahu the stability for chloride ion. So first we need to write the electronic configuration for the chlorine. Okay, so for chlorine atom, the electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p5. So in order to form chloride ion, the chlorine atom need to gain 1 electron dan electron itu akan masuk dekat 3p orbital. Sebab kalau awak tengok 3p orbital ni dia boleh masuk lagi satu electron. So now for the chloride ion, the electronic configuration will be 1s2, 2s2, 2p6, 3s2, 3p6. So if you look at this electronic configuration, the valence electron is now 3s2, 3p6. And kalau awak tengok dia punya electronic configuration, dia akan ada electronic configuration yang sama dengan argon. Okay, so that's why for the chloride ion, okay, the stability dia kita panggil sebagai noble gas configuration. Okay, kita panggil dia sebagai noble gas configuration. Sebab apa? Sebab dia punya electronic configuration ini adalah isoelectronic. Okay, isoelectronic with argon. Sebab argon juga ada 18 elektron. Okay, so the second example, okay, write the electronic configuration and state the type of stability of the ion formed from the atom Sn, okay, to Sn4+. Okay, Sn is an atom with 50 proton. So kalau kita tulis electronic configuration for Sn, okay, dia akan jadi krypton, okay, 5s2, 4d10, 5p2. Okay, in order to form Sn4+, okay, kalau awak tengok daripada Sn ini, valence orbital dia adalah 5s2 and 5p2. So in order to remove 4 electron, kita akan remove daripada 2 electron daripada 5s, and then kita akan remove 2 electron daripada 5p. So for Sn4+, the electronic configuration will be krypton 4d10. So kalau awak tengok electronic configuration ni, semua orbital dalam tu telah diisi dengan elektron. Okay, mana kita panggil sebagai fully filled orbital. Okay, so for this one, we call it as a pseudo noble gas configuration. Sebab apa? Sebab dia bukan noble gas punya configuration, tapi kita panggil pseudo sebab semua orbital dalam itu telah penuh diisi dengan elektron. Okay, and the last one, okay, write the electronic configuration and state the type of stability of the ion formed from the atom Fe to Fe3+. Okay, for ferrum, ferrum have 26 electrons. So ferrum, so 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. In order to form Fe3+ ion, okay, so kita akan remove first daripada 4s 2 elektron, and then kita akan remove 1 daripada 3d. So dia akan jadi 1s2, 2s2, 2p6, 3s2, 3p6, 3d5. So kalau awak tengok 3d5 ini adalah half field stability. Sebab d orbital maximum number of electron that can be accommodated for d orbital is 10. So the half field for d orbital is equals to 5. That's why for Fe3 plus ion, the stability we call it as the half field stability of electronic configuration. Okay. So, now kita dah belajar pasal Lewis dot symbol dan kita belajar pasal the stability of the ion. Okay, we can go into the chemical bonding. Okay, ada three different type of chemical bonding that you're going to learn in this chapter. Okay, the first one is ionic or electrovalent bond. The second one is covalent bond and the third one is dative bond. So we're going to start with the simplest one, which is the ionic bond. Okay, so ionic sometimes we call it as a electrovalent. So sebagai electrovalent bond. Okay, ionic or electrovalent bond is basically an electrostatic interaction between the positive and also the negatively charged ion. Dia hanyalah electrostatic interaction. Okay, in the ionic bond, the metal, we call it as the more electropositive. Okay, hari tu dalam chapter periodic table, awak belajar tentang electronegativity. Electropositivity is the opposite of electronegativity. So that means any element that have low electronegativity, dia akan ada higher electropositive. So electropositivity is basically the tendency for the atom to release ataupun to donate electron. So the higher the electropositivity, then the easier for the element to donate its electron. So metal we consider have higher electropositive. Sebab metal lagi senang nak donate dia punya electron in order to achieve octet. Okay, while a non-metal we call it as a more electronegative. Sebab non-metal dia lagi senang nak attract electron dekat diri dia. So awak kena ingat, kalau nak lukis ionic bond punya formation, nak tunjuk, the electron must come from metal. Reason dia sebab apa? Sebab metal is more electropositive. So metal lagi senang nak donate dia punya electron. Okay, so for example, kita tengok the formation of ionic bond between sodium, between sodium and chlorine. Okay, for sodium dia punya electron configuration is 1s2, 2s2, 2p6, 3s1. For chlorine is 1s2, 2s2, 2p6, 3s2, 3p5. So between sodium and chlorine, sodium is a metal. So that means it's easier for sodium to donate its electron. Sebab apa? Sebab sodium is more electropositive. So in order to form Na+, sodium need to release one electron. And the electron must be donated from the highest energy orbital, which is the 3s orbital. So dia akan donate elektron, satu elektron ni akan pergi kepada 3p5 dalam chlorine. So now chlorine dia akan gain satu elektron to form Cl-. So in order to show the formation of the ionic bond, we're going to use the Lewis dot symbol. Okay, so sodium, so we know that sodium only have one valence electron, so kita hanya perlu draw one dot. Okay, plus chlorine ada 7 valence electron, kita kena draw 7 dots. So 1, 2, 3, 4, 5, 6, 7. Okay, we know that the electron must come from sodium because sodium is more electropositive. So, sodium ni dah akan donate dia punya valence electron, dia akan pergi dekat chlorine. Okay, untuk represent ion, the ion must be drawn in a square bracket. Okay, dan kalau awak nak lukis ion untuk salt, kita mesti lukis cation dulu, baru kita lukis dia punya anion. Okay, since sodium dia dah release dia punya valence electron, so kosong je lah. Sebab dia dah release dia punya satu, dan jangan lupa dia punya charge. Sebab sodium release 1 electron, so dia akan jadi Na+. Chlorine, okay, chlorine gain 1 electron. So right now chlorine ada 8 valence. 1, 2, 3, 4, 5, 6, 7, 8. Then chlorine, since chlorine gain 1 electron, the charge for the chlorine is minus. Okay, so if the question asks you to show the formation of ionic bond by using Lewis dot symbol, okay, inilah cara dia. So awak tunjuk, awak menggunakan ini, kita panggil dia sebagai curly arrow. Okay, curly arrow function dia to represent the movement of electron. Dia menunjukkan macam mana elektron tu bergerak daripada satu atom ke atom yang lain. Okay, another example is shows the formation of ionic bond between magnesium and bromine. Okay, so magnesium, okay, magnesium is element from group 2. So that means magnesium have 2 valence electron. So dia ada 2 dots. Okay, while bromine is an atom from group 17. So maknanya bromine dia ada 7 valence electron. Okay, so in order to achieve stable octet configuration, the magnesium need to donate 2 electron to bromine. Okay, so tapi satu bromine hanya boleh gain 1 electron. Okay, so awak tengok, so magnesium dia donate 1 electron sini. So now bromine yang ini, okay, bromine ini dah cukup dah, octet dah dapat 8. Tapi magnesium ada lagi satu lebihan valence electron. So cara dia, kita wujudkan lagi satu bromine. So kita wujudkan lagi satu bromine. So kita lukis dia punya valence electron. So this 1 electron boleh kita donatkan dekat lagi satu bromine. So now both bromine already achieve stable octet, and same goes with the magnesium. Sebab magnesium also sekarang since dia donate 2 electron, dia juga dah achieve a stable octet configuration. Okay, remember that ion kita kena draw dalam square bracket. So ingat nak lukis, kita kena lukis ion dulu. So Mg, sebab Mg dah donate both dia punya elektron, so dah tak adalah. Okay, so Mg dia akan hasilkan Mg2+. Okay, since awak ada 2 bromine, since kita ada 2 bromine, kita tulis 2 besar-besar. Kita buat square bracket bromine. So bromine sekarang dah ada 8 valence elektron sebab dia dah dapat daripada magnesium. Dan bromine, since each bromine only receive 1 electron, so dia punya charge hanyalah minus. Okay, ini adalah if the question ask you to show the formation of the ionic bond by using Lewis dot symbol, awak buat macam ni. Okay, so the general properties of ionic bond, yang ini sama je macam awak belajar waktu sekolah menengah. The first one, ionic bond is normally is a very hard compound, rigid and brittle. Okay, so contohnya macam garam. Okay, garam yang awak makan itu is a sodium chloride. So okay, sodium chloride is example of ionic bond. Dan sodium chloride kalau awak tengok dia dalam bentuk kristal. Dalam bentuk kristal, dalam bentuk solid, dan dia agak keras. Okay, dan ionic bond is able to conduct electricity when either melted ataupun aqueous state. Aqueous state tu maknanya dalam bentuk solution, maknanya awak dah dissolvekan ionic compound itu dalam water. So melted tu basically awak just cairkan je lah, tak ada air. So when the ionic bond or the ionic compound is either melted or in aqueous state, dia akan dissociate dalam bentuk ion. So maknanya dia akan ada free electron. The presence of the free electron itu yang akan menyebabkan electricity itu boleh mengalir. Okay, and the last one, generally the ionic compound have a higher melting and boiling point compared to covalent compound. Reason dia sebab the interaction ataupun the forces of attraction between the positive and negative charge in ionic bond is stronger than in the interaction dalam the covalent bond. Okay, settle ionic bond, kita masuk for the second type of chemical bond, which is a covalent bond. Okay, tadi ionic bond form through the donating ataupun gaining electron. So maknanya berlaku the movement of electron, maknanya elektron tu bergerak dari satu elemen ke satu elemen yang lain. Covalent bond, okay, covalent bond is formed through the sharing of electron. Sharing electron maknanya elektron tak bergerak. So maknanya awak tak memerlukan curly arrow nak tunjukkan the formation of covalent bond. Sebab curly arrow yang tadi hanya menunjukkan movement of electron. So kalau elektron tak bergerak, maknanya awak tak perlu guna curly arrow. Covalent bond, dia terhasil when the two elements sharing electron. Macam mana dia sharing electron? The electron is shared by overlapping of orbital. Ingat chapter 2 kita belajar p orbital, s orbital, d orbital. Those three orbital dia boleh overlap antara satu sama lain untuk form covalent bond. Yang ini kita akan belajar dalam chapter ni juga, kita akan belajar next week. Waktu kita belajar hybridization. Okay, compound with a covalent bond can either form single, double or triple bond. Dia boleh form 3 different type of bond. Dia either boleh form single, double or triple. Okay, we start with the formation of the single bond. Okay, single bond form when two atoms share a pair of electron. Okay, the covalent bond is called single bond. Kalau awak nampak a pair, maknanya dia share dalam bond tu ada 2 electron. So for example, the easiest example for the formation of the single bond untuk covalent bond is the formation of hydrogen gas. Okay, hydrogen gas is formed when two hydrogen atom share electron. Okay, hydrogen, we know that hydrogen only have one valence electron. Okay, hydrogen sahaja, hydrogen and helium are two element yang akan form duplet. Maknanya in order to become stable, dia akan form duplet. Maknanya dia hanya ada 2 electron. So sekarang ni each hydrogen only have valence electron. In order to achieve a stable duplet electronic configuration, each of the hydrogen contribute 1 electron. So dia gabung, dia jadi 2. So since ini dia just sharing maknanya tak perlu tunjukkan curly arrow. Okay, dia dah share satu pair elektron dan ini juga kita boleh draw dia sebagai satu line. Satu line menunjukkan single bond dan satu line bersamaan dengan 2 elektron. So awak kena ingat, one line bersamaan dengan 2 elektron. Okay. So another example, okay, so for a double bond, okay, tadi single bond they share a pair of electron. Double bond pula they share 2 pair of electron. So for example is the formation of oxygen gas. Okay, so oxygen is group 16, so dia ada 6 valence electron. So awak lukis 6. 1, 2, 3, 4, 5, 6. Okay, tambah lagi satu oxygen. 1, 2, 3, 4, 5, 6. Okay, each oxygen need another 2 electron in order to achieve octet stable electronic configuration. Okay, so maknanya kalau awak lukis, okay, this one and this one dia akan share dengan ini yang saya highlight tu. Okay, so dia akan share 4 electron in the middle to form a covalent bond. Okay, tadi saya cakap 2 elektron bersamaan dengan satu line, bersamaan dengan satu bond. So kalau ada 4 elektron, dia bersamaan dengan double line. Ataupun kita boleh lukis dia macam ini. Sebab kita ada 4 elektron kan. So 4 elektron kita boleh lukis dia sebagai double line. Okay, elektron yang involve dalam bonding ini, kita panggil dia sebagai bonding pair elektron. Elektron yang involve dalam bonding kita panggil sebagai bonding pair elektron. Elektron yang tak involve dalam bonding we call it as a lone pair elektron. So ingat, elektron yang involve dalam bonding kita panggil sebagai bonding pair. Elektron yang tak involve dalam bonding kita panggil dia sebagai lone pair. Okay, the next one is the triple bond. Okay, triple bond form when two atoms share 3 pair of electron. Okay, 3 pair of electron. So for example, is nitrogen gas N2. So nitrogen is group 15. So maknanya dia ada 5 valence electron. So dia ada 5 valence electron. So each nitrogen need another 3 electron in order to achieve a stable octet electronic configuration. So dia akan share 3 pair of electron. Dan kalau 3 pair of electron, okay, kita boleh lukis dia sebagai 3 garis. Macam ni. So yang ini kita panggil dia sebagai triple bond. So ingat, kalau the covalent bond dia boleh form either single, double or triple. Okay, single bond ada 2 elektron, double bond ada 4 elektron, and the triple bond ada 6 elektron between the two atoms. Dan any electron that involved in the bonding, we call it as the bonding pair, and any electron that does not involve in the bonding, we call it as the lone pair electron. Lone, maknanya dia tak dengan siapa-siapa. That's why we call it as the lone pair electron. Okay, bond length, so awak juga kena belajar sebab dalam covalent bond kita ada single, double and triple. The length of those 3 bonds are different. Okay, normally bond length we compare between carbon and carbon. Okay, so generally as the number of bond between the carbon increase, the bond length akan decrease. So that means carbon single bond carbon have higher bond length compared to carbon double bond carbon. And the carbon double bond carbon will have longer length compared to carbon triple bond carbon. So lagi banyak bond between the carbon atom, the bond length will be reduced. So maknanya lagi banyak elektron yang concentrated dekat antara 2 carbon tu, maknanya lagi banyak elektron yang concentrated dekat nucleus. Okay, that's why in term of the strength, triple bond akan lagi stronger dari double bond, dan double bond akan lagi stronger compared to a single bond. Okay. So, the last type of bond that you're going to learn is the dative bond. Okay, dative bond is almost similar to covalent bond. Okay, however, dative bond ni involve the overlapping of a fully filled orbital and also empty orbital. Okay, so dalam dative bond kita ada 2 type of atoms. So we have donor atom and then also acceptor. So the requirement for the donor atom ini, dia mesti have at least one lone pair electron. Okay, dia mesti ada at least one lone pair electron on the atom. Okay, dan the requirement for the acceptor dia must have empty orbital. Dia mesti ada orbital yang kosong supaya dia boleh terima kedua-dua elektron. Okay, then dative bond ni is another type of covalent bond that form when they share a pair of electron. They share pair of electron from the donor atom to the acceptor. Dan donor atom, awak kena ingat, mesti ada at least satu lone pair. The acceptor dia mesti ada empty orbital. Okay, the first example for dative bond is NH4+. Okay, so NH4+ form when H+, H+ react with NH3. Okay, dia react with NH3. So, if you draw the structure of NH3, awak akan nampak ada satu lone pair on the nitrogen. Okay, dan H+, okay, H ada satu elektron. Okay, dekat 1s orbital. So when you remove the 1 electron in the 1s orbital to become H+, right now the 1s orbital is already empty. Dia dah kosong. So that's why the NH3 we call it as the donor, and then H+ ini kita panggil dia sebagai acceptor. So the donor molecule ini, the donor molecule we share both of its electron. Okay, dia akan share both of its electron kepada H+. So lone pair electron yang dekat donor ini, dia akan share kepada empty orbital dalam H+. So macam mana nak lukis dia punya dative bond? Ingat, sebab dia akan hasilkan ion, and ion kita kena lukis dia dalam square bracket. Okay, so kita lukis dulu H ni. Okay, since nitrogen ni dah donate dia punya lone pair pergi ke hydrogen. Okay, for dative bond normally we draw as a arrow. Arrow itu mesti menuju daripada donor ke acceptor, dan acceptor kita adalah H+. So ini adalah how you can show the formation of dative bond by using a Lewis dot symbol. Okay, the last one, okay, the last example is H3O+. Okay, H3O+ for when you have H plus H2O. Okay, H2O, the structure of H2O is like this. Okay, so kalau awak tengok between H2O and H plus, H2O we call it as the donor sebab H2O ni sekarang yang ada lone pair. H plus kita panggil dia sebagai acceptor sebab dalam H plus ni yang ada empty orbital. So H2O akan donate one pair of its lone pair kepada H plus. Dia akan donate kepada empty orbital dalam H plus. So awak lukis H2O ni dulu. Okay, awak lukis H2O ni dulu. Okay, since kita dah donate satu pair elektron, dia akan ada lagi satu pair. So, anak panah tu mesti datang daripada donor ke acceptor. Dan acceptor kita adalah hydrogen ion. Dan since ni adalah ion kita kena lukis dia dalam square bracket and don't forget the charge. Okay, for today, this is just for today. So, for next lesson, we're going to learn about the Lewis structure and also the formal charge. Lewis structure is basically how you're going to draw the structure of the covalent bond. And formal charge ni kita gunakan macam mana kita nak tahu Lewis structure yang kita lukis tu stable ke tak. Okay, so that's all for today. Thank you everyone.